Hello, everyone. How are you? I trust you're all doing great. James from JTS Maths Tutoring here. Today, we are going to be looking at an example of graphs and functions. So we are given this question here. Let f be the function f of x is equal to x squared plus 4x or that over 2 minus 2 ln x plus 3 for x is greater than negative 3. The first question showed that the first derivative of f of x is x plus 4 multiplied by x plus 1 all that over x plus 3. The second question, use the sign pattern for the first derivative of f of x to determine the intervals where f rises and where f falls. The third question, outline how to find extreme points and determine the local extreme points of f. Beautiful. Let's get going. I want you to know and understand that the given function can actually be written like this. So let's get going. What is the derivative of x squared is 2x multiplied by 1/2 is going to be our x here. What is the derivative of 2x? It's going to be 2, which is the 2 that you're seeing here. What is the derivative of 2 minus 2 ln x plus 3? Okay, the derivative of ln x plus 3 is 1 over x plus 3 multiplied by the derivative of the inside function here. So we are making use of the chain rule here, for which the derivative of x plus 3 is just going to be a 1. So we have minus 2 multiplied by 1 over x plus 3, which is minus 2 over x plus 3, which is what we have right here. Then we are going to rewrite this as a quotient. So we have x plus 3 is our common denominator. 1 into x plus 3, that's x plus 3 multiplied by x plus 2, which is what you see right here. X plus 3 into x plus 3, that's going to give us a 1 multiplied by negative 2, which is what you're seeing right here. Our next step is to expand this x multiplied by x, that is x squared, x multiplied by 3, that is a 3x, 2 multiplied by x, that is a 2x, 2 multiplied by 3, that is a 6 there. So we have x squared plus 3x plus 2x plus 6 minus 2, which is actually going to give us x squared plus 5x plus 4. Our next step is to actually factorize this numerator here, which is going to give us these two factors, x plus 4 multiplied by x plus 1. Boom. We have managed to show what they wanted us to show them. Right. So the second question is now making use of the sign pattern for the first derivative of f of x to determine where f is rising and where it is falling. Right. So from what we have right here, we are going to get critical points. What are critical points, which are also known as critical values or stationary points? These are simply points where the first derivative of the given function is equal to 0, or where the first derivative of that very given function is what undefined or does not exist. So right, if you equate this equal to 0, you see that the critical points for the first derivative of f of x are minus 4, minus 3, and negative 1. These critical points, they actually split the number line into 4 distinct intervals, which is we have numbers which are less than, or values which are less than minus 4, and the values which are within this interval, minus 4 and minus 3, and minus 3 and minus 1, and numbers which are, or values which are greater than negative 1. All right, beautiful. So we have to draw up our sign pattern or our sign table, but I want you to take note that I have 4 distinct intervals here, but on my sign pattern, I am only having 2 intervals. Why? Because this is a logarithmic function, so we are only going to be looking at those values which are not going to make the function to be what? To be undefined, which you can see that right here, if you use all the numbers less than 4, it's going to make the function to be undefined. The same applies to this interval as well. Remember the restrictions, the domain restrictions, when the function was actually defined, it was defined for all values greater than negative 3. This is the reason why we don't have those 2 intervals there. Right. Okay, beautiful. Right. We have all our factors here, and the sign in the sign pattern is actually obtained by substituting any value within the given interval into these highlighted factors here, and then observe whether the final value, is it positive or negative? Okay, let's get going. I can take negative 2, which is within this interval. Negative 2 plus 4, that's going to give me a 2, which is positive. Negative 2 plus 1 is going to give me a negative 1, which is negative here. Negative 2 plus 3 is going to give me a positive, which is okay, beautiful. Right, but we know that multiplying a positive number with a negative number is going to give us a negative number, and the negative number divided by a positive number is going to give us what? So this is going to be the final one. All right, beautiful. Now coming to this interval, let me take, say, 2. 2 plus 4, that's going to give me 6. 2 plus 1, that's going to give me a 3. 2 plus 3 is going to give me a 5, all which are positive, right? This is going to be the final one here. Right, and I want you to also understand that when you are dealing with your sign pattern, any factor which is always going to be positive, there's no need for you to actually include it on the sign pattern or the sign table, because it's not going to affect the final outcome. Like this one, we could even have actually done away with it. It was not going to change anything. Right, now I want you to know and understand that when you are using your sign pattern or sign table, F falls where we have the final outcome where it is negative on the sign pattern, and F rises where we have got a positive. So it means this one is actually falls within this interval right here, because this is where we have a negative sign here, and it rises within this interval here because this is where we have a positive sign right on the sign pattern. Beautiful. Now we want to go ahead and find out how do we determine the extreme points. All right, you can see again on this left side, these notes I've already explained them just a few minutes ago. So when a factor is always positive, we do not include it in the sign pattern since it doesn't change the sign of the final outcome. F rises with their positive signs on the sign table. F falls with their negative signs on the table. So you have already seen that. Okay, beautiful. But for us to get our extreme points, we can set the first derivative of f of x to be equal to 0, and then we solve for x. Then we'll get the x coordinate. Then we plug in that x coordinate into the original function, not into the first derivative of f of x. Take note of that, right? Or we can go with our first derivative test. We can read from the sign table, or we can actually draw a sketch of the function. Okay, you can actually refer to the notes under extreme points, which is what we have right here. You see when we go down. Okay, or you can make use of the second derivative test. All right, so suppose the second derivative is continuous near a critical point. This is how to go about it right here. Okay, beautiful. So let's get going. You can see here, I've actually set this to be equal to 0. I've got x is equal to b minus 4, and I've got x is equal to 1 right here. So we're actually going to discard it. X is going to be equal to minus 4 because of the domain restrictions. So I'm going to leave this for you guys to actually prove whether what I was doing here, did I get the correct values here. Another way which could actually have done this was just going to go straight and read this stuff from the sign table or the sign pattern there. All right, cool guys, there we are. This is what we had for you for today. Allow me to do what my mama taught me. A good visitor knows when to leave, or she would say a good dancer knows when to leave the dance floor. Adios, amigas and amigos. Till we meet again, be rest assured at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Bye-bye. See you soon.